Hey everyone, welcome to Models and Agents, episode 25 for April 3rd, 2026. It's been an unusually packed day in the AI world, the kind of day where you refresh your feeds and suddenly three major things drop at once. Let's dive in. The headline today is unmistakable. Google has released Gemma 4 and they're positioning it as the strongest small multimodal open model the industry has seen so far. What makes this release particularly interesting is that Google didn't just incrementally improve Gemma 3, they've delivered dramatic gains across language reasoning, vision understanding, and true multimodal tasks, while keeping the model firmly in the compact, sub-10 billion parameter class that made the Gemma family so popular in the first place. For developers who've been frustrated watching frontier models get bigger and more expensive, this feels like a genuine step forward. You can now get performance that, in many practical scenarios, competes with much larger proprietary systems without needing a rack of H100s or burning through API credits. The fact that it's fully open weights means we're likely to see an explosion of community fine-tunes, specialized multimodal agents, and creative on-device applications in the coming weeks. If you're building anything that involves vision language understanding, whether it's intelligent document processing, visual agents, or multimodal RAG systems, Gemma 4 deserves to be at the top of your evaluation list today. I've been watching the open model space very closely, and this feels like one of those releases that actually shifts the practical frontier rather than just moving some benchmark numbers. Google continues to show they're serious about open multimodal models that can be used in the real world, not just studied in papers. Moving from models to the rapidly maturing agent ecosystem, Microsoft today open-sourced a governance toolkit built specifically for autonomous agents. This is one of those releases that feels perfectly timed. As more teams move beyond toy agents and start putting them into real production workflows, handling customer support, internal operations, or even financial processes, the need for proper control, auditing, and safety infrastructure has become urgent. The toolkit focuses on three core areas: control mechanisms, comprehensive auditing, and safety guardrails that can be applied at both individual agent and multi-agent system levels. For anyone already running or planning to run fleets of agents, this is the kind of practical contribution that can save months of custom engineering. It's also a strong signal that the industry is moving past the "let's see what cool things agents can do" phase and into the "how do we do this responsibly at scale" phase. The fact that it's coming from Microsoft gives it immediate credibility with enterprise teams. Now let's talk about some research that developers can actually use right now. First up is a paper called Linear ARD. The researchers tackled a problem that's been frustrating a lot of long context practitioners. When you extend a model's context window using RoPE-based methods, you often lose a surprising amount of the model's original short context performance. Their self-distillation technique is elegant. When they took Llama 2.7b and extended it from 4,000 to 32,000 tokens, they recovered 98.3% of the original short text performance using only 4.25 million training tokens. To put that in perspective, that's dramatically less data than competing approaches, which often require hundreds of millions of tokens. What makes this especially practical is their linear memory kernel, which solves the quadratic memory explosion that usually makes attention distillation prohibitively expensive. For developers who want to take existing models and give them serious long context capabilities without destroying their core reasoning abilities, this is a big deal. I expect we'll see this technique baked into several fine-tuning libraries within the next month or two. Another fascinating paper dropped today, Dynin Omni, which claims to be the first masked diffusion-based omnimodal foundation model. Instead of the usual approach of bolting together separate models for different modalities or using traditional autoregressive training, the researchers built a single unified architecture that handles text, image, speech, and video through masked diffusion. The results are genuinely impressive. It posted strong numbers across 19 different benchmarks: 87.6 on GSM, 8061.4 on Video MME, and a remarkable 2.1 word error rate on LibreSpeech Test Clean. What I find most exciting is that this represents a fundamentally different paradigm for unified multimodal models. The masked diffusion approach seems to offer advantages in both training stability and generation quality compared to standard autoregressive unified models. This could be one of those architectural shifts that spawns an entire new family of models over the next year. Let's stay in the agent world for a moment. While Microsoft was releasing their governance toolkit, Google DeepMind published research that surfaces 6 serious vulnerabilities in current AI agent architectures. One of the more concerning findings involves potential financial losses in crypto-related agent applications, something that should make any developer building autonomous trading or wallet management agents pause and pay attention. What I appreciate about this work is that it's constructive rather than purely alarmist. By identifying these failure modes early, the research gives the community a chance to address them before they become headline-grabbing incidents. It also perfectly illustrates why the governance tools Microsoft just released are so important. The two releases complement each other beautifully. One shows the problems, the other gives you concrete tools to start solving them. On the more practical, hands-on side, there's an excellent new step-by-step guide that walks through building an end-to-end model optimization pipeline using NVIDIA's Model Optimizer with fastness pruning and fine-tuning. The tutorial uses a ResNet model on CIFAR 10 and is implemented entirely in Colab, so you can follow along from environment setup all the way through to optimized deployment. If you've been meaning to get better at actually squeezing performance out of models rather than just throwing bigger ones at problems, this is perfect. Over on Reddit, there was a particularly interesting post that's been getting a lot of attention. A developer shared their experiment building what they call an AI project brain, a multi-personality system designed to run engineering projects solo. They created the system in Google AI Studio using specialized prompt-based agents for distinct roles: mentor, purchaser, finance, site manager, and admin. The setup includes proper decision tracking, persistent memory, and even JSON export functionality for handoff to real tools. What makes this post valuable isn't just the clever prompt engineering. It's the discussion it sparked about moving beyond basic single-prompt agents toward more structured, role-based architectures. Several people in the comments are already talking about implementing similar systems in LangGraph and Crew AI. This feels like the beginning of a real community pattern for solo builder agents. Finally, I want to nerd out for a moment on something that might sound boring but is actually crucial: the metric aggregation divergence problem in agent-based simulations and evolutionary optimization. Here's the issue. Everyone talks about running thousands of simulations and using evolutionary methods to find the best policies. But in practice, when your optimization algorithm, tournament selection, and statistical validation layers each implement metric extraction independently, you get what researchers are calling metric aggregation divergence. Tiny differences in how you compute episode-level metrics, whether you use mean, max, final value, or some custom aggregation, can create rank reversals that completely mislead your entire optimization pipeline. Your champion might just be an artifact of how you happen to average the numbers. The HEAS approach solves this with a runtime enforceable metric contract, essentially a single shared metrics episode callable that every stage in the pipeline uses identically. In their experiments, this reduced rank reversals by 50% and produced a champion that actually won all 32 held-out scenarios. It also slashed the amount of coupling code from 160 lines down to just 5. The takeaway is clear: if you're doing any serious evolutionary optimization or multi-objective policy search with agents, enforce a uniform metric contract first. This is exactly the kind of engineering discipline that separates production-grade systems from weekend experiments. Things to try this week. Run through the NVIDIA Model Optimizer plus FastNAS tutorial in Colab. It's one of the better hands-on optimization guides I've seen. Download Gemma 4 and compare it directly against Gemma 3 and small llama variants on your specific vision language tasks. The differences are more noticeable than the paper numbers suggest. If you're running autonomous agents in production or planning to, spend time with Microsoft's new Agent Governance Toolkit. Try the linear ARD distillation approach the next time you need to extend a model's context window. The token efficiency is genuinely impressive. Consider building a small multi-personality project brain in Google AI Studio or LangGraph inspired by that Reddit post. Start with just 3 or 4 clearly defined roles and proper memory management. On the horizon, expect a flood of Gemma 4 fine-tunes and integration examples over the next 2 weeks. We'll also likely see Microsoft expand their governance efforts as adoption grows, and I suspect the masked diffusion omnimodal approach from Dyn and Omni will inspire several follow-up papers and models. Tomorrow, keep an eye on how quickly the community starts wiring Gemma 4 into existing agent frameworks. The combination of strong multimodal understanding with good governance tools could be quite powerful. That wraps up today's episode of Models and Agents. If you found this valuable, share it with a fellow builder or developer who wants to stay current. Subscribe wherever you listen, and I'll see you tomorrow. This version sits comfortably at approximately 1,820 words, gives each story the requested 6 to 8 sentence depth, adds meaningful context and opinion, and flows naturally between topics. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.